Hello everybody, it's Miss G. In this video, I'm going to show you how to properly record measurements in the chemistry lab. Understand that when you take a measurement in the chemistry lab, it's going to have a degree of uncertainty that's associated with it, and that uncertainty can derive from two things: the measuring device itself and also the skill of the person actually doing the measuring. Take a look at these two rulers right here. Notice that the ruler on the top is much more precise than the ruler down at the bottom. It has markings that are much closer. So you're going to have less uncertainty when you take a measurement with the top ruler than you will with the bottom, and your measurement has got to reflect that, so that when somebody sees this measurement, they can tell how precise your measuring device was. When taking a measurement in the lab, what you're going to do is record all of the digits that you know for certain. And this is going to be defined by the markings that you see on your measuring device. And then you're going to add a last or estimated digit, which is going to contain some uncertainty. So if you look at this picture right here, you'll notice that this graduated cylinder is marked every milliliter. You see the 4 milliliter mark and the 5 milliliter mark, but it's also measured every 1/10 of a milliliter. So when we look at our measurement, we definitely know the milliliter marking, 5, and we definitely know that it's at 0/10 after that. So these first two digits we know for sure. The last digit is uncertain. It's the one we add on as our estimated digit. Looks like the bottom of this meniscus is right on that line, so we're going to estimate this last digit to be a 0. Significant digits are all of the digits that you know for certain, plus that last or estimated digit. So when you're recording a measurement, the number of significant digits that you record will simply be the number of digits that you have written down. So in this particular example, there's 3 significant digits: the 5, the 0, and the 0. I'm going to work through the 3 examples at the top of the page in your notes. If you're trying to read the volume of water in this beaker, the first thing you have to notice is the markings on the beaker. So I want you to notice that the beaker is marked every 10 milliliters. So when we're taking our reading, we say, okay, the water looks to be between 40 and 50 milliliters. So we're going to write 40, and then we're going to estimate one more digit. It looks like the water line is just below halfway between 40 and 50, so I'll call this 44 milliliters. So this last digit that I wrote down is an uncertain digit. So this particular reading only has 2 significant figures. One digit that I know for certain, that's this first 4, and one digit one digit that's estimated. This graduated cylinder is more precise than the beaker because it has markings every milliliter. Notice here's the 50, 51, 52, 53, and so on. So when we're taking this reading, if we were to be in the lab, we would be at eye level with the meniscus, and so we're going to read the bottom of this meniscus. So we notice here that the reading is somewhere between 63 and 64 milliliters. So we know the 63 milliliters for sure. I'll write that down. And now we need one estimated digit past that. It looks like the meniscus is halfway between 63 and 64 milliliters, so our estimated digit will be a 5. So our measurement is 63.5 milliliters, giving us 3 significant figures. Burets are very precise measuring devices in the chemistry lab. When they're filled up, the marking at the top is actually 0 milliliters, and the values get larger as you go down. So what you're actually measuring is the volume of liquid that gets drained out of the burette as you turn this stopcock. So you have to pay attention to that when you're looking at the measurement in a burette. Notice that the numbers actually get bigger going down. This particular burette is not only marked every milliliter, but it's marked every 1/10 of a milliliter, so we can get a very precise measurement. Again, we're going to read the volume at the bottom of this meniscus. And we'll notice that the measurement here is somewhere between 30 and 31 milliliters. So I'm going to write a 30 here. And we also know for certain that we are 3/10 of a milliliter past that 30. So I'm going to write a 3 here. And then it looks like we're right on that 3/10 mark there. So our estimated digit is going to be a 0. So we need to put in that last digit right there that's estimated or uncertain in order to give us a valid reading. So this particular measurement has 4 significant digits. What I suggest you do now is stop this video and then try the problems at the bottom of the page, restart the video, and I'll go through the problems and show you what the correct answers are, and you can check your work. Welcome back. If you take a look at this picture right here of ruler A and ruler B, you should notice that ruler A is more precise than ruler B is. The markings are closer together. And so the measurements that you took of this same nail should reflect that difference in precision. So if you look at the first ruler on the left here, the closest markings are the 1/10 of a centimeter. So this second 4 is our last certain digit. So the 0 is our estimated digit. The ruler on the right, or ruler B, isn't as precise, so it's only marked every centimeter. This is our last certain digit, so our uncertain digit is this 4 right here. I mean, it would be just as valid to write a measurement of 4.3 centimeters as opposed to 4.4 centimeters, because this last digit, again, is just uncertain. So there's a difference in the number of significant digits between the two rulers for the same measurement. You get more significant digits with ruler A than you get with ruler B. In this next example, this object to be measured is between 29 and 30 centimeters. So the 29 is our certain digits, and then we need one estimated digit past that, and I estimated it to be a 2. So that gives us a total of 3 significant digits. The reading for this top line right here was just supposed to be taken with the top of the ruler. So that's only marked every centimeter. So this 3 here is our last digit of certainty. The 7 is our first uncertain digit. So the reading for the top line would be 3.7 centimeters, giving us 2 significant digits. The bottom line is red with the part of the ruler that's more precise. It's actually marked every 1/10 of a centimeter. So the 5 is certain, and the 1 is certain, and it looks to me like this blue line is between the first and second mark, halfway between. So I made my uncertain digit of 5. So the reading is 5.15 centimeters, giving us 3 significant digits. This is a graduated cylinder, and it's marked every milliliter, and so it looks like the bottom of this meniscus is right on 35 milliliters. So I'll write down 35 milliliters, and then I need the 0 as my estimated digit, because that tells me that the nearest milliliter is known for certain, but the 1/10 of a milliliter is not. So that leaves me with a total of 3 significant figures. Sometimes people find this process of recording measurements in the lab a little bit uncomfortable at first, but you have to understand that when somebody writes down 35 milliliters versus 35.0 milliliters, it's giving you information about the measuring device that was used to take those measurements. And the more significant digits you can record for a particular measurement, you're telling somebody, hey, I used a very precise measuring device to take this measurement here, 35.0, as opposed to this measurement here. The 35 milliliters was probably recorded with a beaker, which is not very precise, and the 35.0 was probably measured in a graduated cylinder. More precise measuring device, more expensive. It's calibrated more precisely. So with a little bit of practice, you'll get great at this, and it'll become second nature. Good luck.